10 C's. Here we go as we continue on with the world of trigonometry. So, trigonometry, we are working, as we have been doing for a while, right angle triangles. That's why we have little boxes for symbols, because that does not look like a right angle triangle. That's a little better. There, right angle triangles is what we're dealing with. Junior high, grade 9, grade 8, Pythagoras, the 180 rule. Yesterday in the lesson, the day before, whenever you watched it, the last lesson we talked about finding side lengths. Today we're going to move on to angle sizes. Please, as the last lesson discussed, make sure your calculator is in degree mode. Otherwise, you will do some work, think you have the right stuff, but not. Make sure you're in degree mode. So, continuing on. What's nice with solving angle sizes is process is very repetitious with one significant twist. If you get the twist down, which isn't impossible at all, it's going to be repetitious and nice, easy peasy. So here we go. Now, what we did calculating side lengths yesterday is we were punching in values like tan 24, sine 88. It could have been tan 24 degrees, and we had it equal to x over like 16, and we needed to solve for x, and we cross multiplied. Well, yesterday, what we did was we simply punched in tan 24 times 16. So when we were cross multiplying, we just did tan 24 times 16. That was what we punched into our calculator. However, you will see with the calculator that when we were to just do tan of 24 degrees, it's an actual decimal value. So it's not like the tan 24 is magical, it's a value. And we can do the same thing on that page, like it says sine of 88. The sine of 88 gives us a decimal value. The cosine of 12, cosine 12, it's a decimal value. So these things all give decimal values. We didn't see those before, but they're there. So what we were doing was taking the tan 24 to a decimal, sine 88 to a decimal, cosine 12 to a decimal. Well, what we need to do is when we're calculating angle sizes, we need to take a decimal and say, hey, what's the degree? Here's a decimal, what's the degree? Here's a decimal, what's the degree? Because the decimal is what we're going to be able to calculate now. And what we have to do is inverse trig the decimal value. And inverse trig means you're going to hit the second function button on the calculator. So if we take a look at the examples that are there, when you want to find an angle size, it'll show sine of the unknown reference angle has a decimal value. Well, what we want to do is take the decimal and figure out how big the angle is. And what we do to do that is we need to inverse trig, and we want it to look like that on our calculator. And then we want to punch in the decimal. We want to take tan theta, 2.546, which means we want to inverse tan the 2.546. Well, how do we get that little -1 exponent on the calculator? Second function is what helps us to inverse. So if we want on our calculator to get sine 0.4568, we want second function sine, and then we punch the decimal in, 0.4568. And again, the most important part to this is to make sure your calculator's in degree mode. What do we get? 27.18. That's our angle size now, but angles can always be rounded to a whole degree, unless a question says otherwise. But almost always, you're going to go to a whole degree. The second one we had looked at on that page was the tan theta is 2.546. So like it said, we want second function of tan, which shows us we're inversing the 2.546 decimal. Hit enter, 68.55, which is a 69 degree angle. So Inverse of the 0.4568, that was a 27-degree angle. Inverse of 2.546, that gave us an angle size of 69 degrees. The next two, same thing. We want cosine of some angle degree. We want the sine of some angle B. And we know what the decimal is, so we need to inverse cosine the decimal value. We need to inverse sine the decimal value. And when we do that on our calculator, it will give us the angle size. So let's quickly take a look at those two. What do we want this time? It was, let me go back and double check. It was the cosine and the sine questions. So cosine, second cosine, because we want the angle, 0.5217. Enter. 58.5 or a 59-degree angle. Second function sine, angle B, was 0.7498 equals 48.5 or a 49-degree angle. Now, interesting that these all end with 9s. Please don't assume that every answer ends in a 9. That's just a coincidence with these examples. Now, the only other thing I want to point out really quickly is the fact that the decimal values are 4 decimal places. If I were to get the inverse cosine and I just rounded, said, oh, it's 0.5. Let's do inverse cosine of just 0.5. Well, if we go back and we do inverse cosine of just 0.5 and not 4 decimal places, we end up with a 60-degree angle. Now, the angle that we had was 59. It's close, but it's not the same. This is why decimal values, we need to work with 3 or 4 decimal places. The more specific, the better. Now, second part to this, though, is, well, what if we want to find an angle where we have a fraction? So it's kind of similar to what we had. 2 different things to do. Depends upon what kind of calculator you have, actually. If you have the sort of calculator like the graphing calculator, which you're supposed to have for the course, a little bit quicker way to do it. But if you don't have the fraction capability, well, what we can do is just take our 7/15 and convert it to a decimal. 7 divided by 15 is the same as, again, 4 decimal places, decimal 4667. So I could work with, instead of 7/15, decimal 4667. They both have a similar value. Yes, the decimal 4667 is rounded, but it's still the same essential value. So what would we do here? Well, we could do the inverse sine of 7/15 and punch in the fraction as a fraction in the brackets. Or we could convert it to a decimal and do the inverse sine of decimal 4667. Well, let's check that on our calculator. Well, we had second function sine. Because I can do this on my calculator, 7 divided by 15 in the brackets is like the fraction 7/15. I get 27.81 blah, 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 a 28-degree angle. If I do the inverse sine of the decimal equivalent of 7 divided by 15, I get the same sized angle. Now we see the smaller decimal values are different, but that's because 7/15 and 0.4667, the 0.4667 is rounded, but we can see it's very close. And how big is the angle? 28 degrees. So both of those doesn't matter. This situation, theta is 28 degrees. So cosine of C, 179/200, could also be cosine C, and instead of 179/200, I could put decimal 895. Now, decimal 895 isn't 4 decimal places, but that's because it actually terminates at 3. So if I do the angle calculation inverse cosine, second cos, of 179 over 200 divided by 200, 26.49, 26-degree angle. If I do second cosine of the decimal equivalent, which is 0.895, we get the exact same angle, a 26-degree angle. Angle C is 26 degrees. So tan Y, you can check that one, both work. But if I were to do tangent Y inverse, I would just punch in the 87 over 11 because I can on my calculator, and we get Y to equal 83 degrees. So that's the key for calculating angle sizes. What did we do last lesson with calculating side lengths? We identified the reference angle. We labeled the sides, hypotenuse, opposite, adjacent. We chose the trig ratio, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. And we chose those based on what information was given to us. We substituted the values into the trig ratio, and then we solved by cross multiplying. Well, we solved by cross multiplying to find side lengths. I've said a couple times in these lessons, trig is repetitive. Step 1, 2, 3, 4 don't change. We're no longer going to cross multiply. When I switch it up, identify the reference angle, label the sides, choose the trig ratio, substitute the values in. But when we solve, we're now going to inverse trig the ratio, which we just talked about. Steps don't change. Here we go. Identify the reference angle. Still need to do it, but this time, if we're trying to find an angle, the reference angle is to choose the angle you need. If I want to find angle X, let's use angle X for the reference angle. Label the sides. Opposite the 90 is hypotenuse. Across from the reference angle is the opposite. Leaves us with adjacent. Label the sides, choose the trig ratio. Well, I need information to find something I don't know, and since I have opposite and adjacent, hypotenuse isn't helpful. So without the hypotenuse, I'm left with tangent because I have the opposite side and the adjacent side. So tangent, always finish it, that part. Make sure your reference angle goes into your little equation. Tangent is opposite over adjacent. And now we've substituted the values in. How do we solve? This is what we spent the first 10 minutes of the video talking about. What do we do? Second function, or inverse tan, 17 over 12. So inverse tan of 17 over 12, second function tan, 17 divided by 12. There we go, 54.78, which is a 55-degree angle. So angle X is 55 degrees. There we go. That's straightforward, hopefully. Same first 4 steps, and now the 5th step's not overly complicated. Page 16, number 4, number 6. Pause the video, give it a try. Let's see what you come up with. All right. Hopefully you tried these and aren't just going to write down my steps, but you did some thinking. Here we go. First thing, we want to find theta. There's our reference angle. Opposite. Theta is opposite. Opposite the 90 is hypotenuse. Leaves the adjacent. Well, which piece of information is of no use to us? Well, we have those two. Adjacent doesn't help. So now we think SOHCAHTOA. Opposite hypotenuse, we're using sine here. Sine of the unknown angle theta is opposite 6 over hypotenuse 10. We don't cross multiply because we're finding the angle. We need to inverse sine 6 divided by 10. And when we do that, inverse sine of 6 over 10, we get an angle of 37 degrees. Number 6, reference angle, theta, Label, opposite the 90, hypotenuse. Across from the reference angle is opposite. Leaves us with the adjacent. I have adjacent and hypotenuse. Opposite does nothing. Adjacent and hypotenuse. There it is. Cosine theta. Adjacent over hypotenuse. How do we find an angle? Inverse trig. Oh, you're getting sick and tired of me saying that, but it's the key parts. And theta, 8 2/10 divided by 10, inversed, leaves us with theta equal to 35 degrees. Calculating angle sizes. Not overly complicated, hopefully. All right, last one, question 5. Skipped over it, now we're back at it. Only because this is such an easy question, because it takes away some of your thinking, but I just find students panic. So we still want to find theta. We label the sides, hypotenuse, opposites, adjacents. But now when we choose the trig ratio, I get students that panic because there's no extra piece. No, there isn't, which means if I have all opposite, hypotenuse, and adjacent, we can use all 3 trig ratios, sine, cosine, and tangent. So pause the video, find angle theta 3 times using that information. Let's see what you get. So here we go. Sine to start with. We want sine of theta, opposite 5 over hypotenuse 13. We want the inverse of 5 over 13. And inverse sine 5 over 13 gives us a value of theta equal to 23 degrees. Cosine theta. Well, what should we get for theta? Let's even put our answer down here. It had better be 23 degrees because it doesn't matter how we find that angle. The angle shouldn't change. So cosine of theta. Cosine is adjacent over hypotenuse. 12 over 13. What do we do to find the angle? Inverse cosine, 12 divided by 13. When we punch that in, there's our 23 degrees again. Tangent, going to get the same thing. Where are we? Tangent, theta. Tangent is opposite over adjacent. 5 over 12. Get an angle, tan inverse, of 5 over 12. And when we inverse tan 5 over 12, theta is 23 degrees. Doesn't matter which trig ratio you use, it should work the same every time. So, assignment, booklet, page 16, all of it. This is simply calculator work. Yeah, it might be a bit of a drag, but you need to ingrain in your brain that you need to inverse trig to get an angle only. Page 17, number 2 and 3. That's going to basically cover finding angles. However, page 18 and 19 in the booklet, these are great practice questions because this doesn't tell you whether you're finding a side or an angle in a particular lesson. The first lesson was sides. Second lesson today was angles. But these questions, you have to decide. Are we calculating a side or an angle? You have to make some decisions. And then you have choices. Pythagoras is always a choice. If you don't have an angle, maybe Pythagoras will work. The 180 rule. Well, sometimes you have to go through all the trig. If you have 2 angles, you can find the third angle because of the 180 rule. And then you have the trig ratios. And the trig ratio is very similar, but that key last step. Side length, we cross multiply. Angle size, we inverse trig. You need to keep this stuff straight. So my suggestion is you get some of that done for practice as well. Practice it. It's not complicated, but you need to keep the steps straight. Have fun.